The universe is expanding, but not just expanding. It's accelerating, as if some invisible force is pushing galaxies apart faster and faster. Imagine throwing a ball into the air and watching it speed up instead of slowing down and falling back. That's exactly what's happening on a cosmic scale. Scientists call the mysterious cause behind this phenomenon dark energy, and it may be the most powerful and least understood force in the universe. So what exactly is dark energy? To understand dark energy, we first need to step back and look at how scientists discovered that the universe is expanding. In the 1920s, astronomer Edwin Hubble observed that galaxies are moving away from us in all directions. This led to the idea that the universe began with a Big Bang and has been expanding ever since. For decades, scientists assumed that gravity, the force pulling matter together, would gradually slow this expansion over time. But in the late 1990s, something surprising happened. Two independent teams of astronomers studying distant supernovae, exploding stars, made a shocking discovery. Not only was the universe still expanding, but the expansion was actually speeding up. This was completely unexpected. Gravity should have been pulling everything back together, slowing things down. Instead, something unknown was overpowering gravity and pushing the universe apart. That something was named dark energy. Dark energy is not something you can see, touch, or directly detect. It doesn't emit light or energy in any traditional sense. In fact, scientists call it dark, not because it's black or shadowy, but because it is invisible and mysterious. It does not interact with matter in ways we can easily measure. Instead, its presence is inferred through its effects on the universe's expansion. What makes dark energy even more fascinating is how much of the universe it makes up. You might think that stars, planets, and galaxies dominate the cosmos, but they only account for about 5% of the total universe. Dark matter, a different mysterious substance, makes up about 27%. The remaining 68%, that's dark energy. In other words, most of the universe is made of something we don't understand. So what could dark energy actually be? One leading idea is that dark energy is a property of space itself. Even empty space isn't truly empty, it has energy. This concept is rooted in quantum physics, which suggests that tiny particles constantly appear and disappear in what we think of as vacuum. If space itself has energy, then as the universe expands and more space is created, more of this energy appears. This could explain why the expansion is accelerating. The more space there is, the more dark energy exists to push things apart. This idea is often linked to something called the cosmological constant, a concept originally introduced by Albert Einstein. Einstein added this constant to his equations of general relativity to allow for a static universe, which was the prevailing belief at the time. Later, when the universe was discovered to be expanding, he reportedly called it his greatest mistake. Ironically, the cosmological constant may actually describe dark energy quite well. Another possibility is that dark energy is not constant at all, but changes over time. Some scientists propose the existence of a dynamic field called quintessence, which evolves as the universe expands. Unlike the cosmological constant, which assumes a steady energy density, quintessence would mean that dark energy could vary, potentially leading to different outcomes for the universe's future. Speaking of the future, dark energy plays a crucial role in determining what will ultimately happen to the universe. If dark energy continues to dominate and remains constant, the universe will keep expanding forever, growing colder and emptier over time. Galaxies will drift farther apart, stars will burn out, and the universe will eventually become a dark, silent place, a scenario known as the Big Freeze. However, if dark energy increases in strength, it could lead to a much more dramatic ending called the Big Rip. In this scenario, the expansion becomes so powerful that it eventually tears apart galaxies, stars, planets, and even atoms themselves. Everything would be pulled apart at the most fundamental level. On the other hand, if dark energy weakens or reverses, gravity could eventually take over, causing the universe to collapse back in on itself in a big crunch. While this idea is less supported by current evidence, it shows how central dark energy is to understanding the universe's fate. Despite decades of research, dark energy remains one of the biggest mysteries in modern science. Scientists are using powerful telescopes, satellites, and experiments to study it more closely. Missions like the Euclid Space Telescope and the Nancy Grace Roman Space Telescope aim to map the structure of the universe and track how galaxies move, providing clues about how dark energy behaves. One of the challenges in studying dark energy is that it operates on incredibly large scales. We can't recreate it in a lab or observe it directly. Instead, scientists rely on careful measurements of distant galaxies, cosmic background radiation, and gravitational effects to piece together its properties. Dark energy also raises deep philosophical questions. If most of the universe is made of something we can't detect or fully understand, what does that say about our place in the cosmos? It challenges our assumptions about reality and reminds us that there is still so much to learn. It's also worth noting that dark energy is different from dark matter, even though the names sound similar. Dark matter acts like an invisible glue, holding galaxies together through gravity. Dark energy does the opposite. It pushes things apart. Together, these two mysterious components shape the structure and evolution of the universe. As research continues, scientists hope to uncover the true nature of dark energy. Is it a fundamental property of space, a new kind of energy field, or something even more unexpected? Each new discovery brings us closer to understanding the invisible force that is driving the universe's expansion. For now, dark energy remains a cosmic puzzle, one that sits at the intersection of physics, astronomy, and philosophy. It is a reminder that even in an age of advanced technology and scientific knowledge, the universe still holds secrets that challenge our imagination, and perhaps that's what makes dark energy so captivating. It's not just a scientific concept. It's a mystery that stretches across billions of light years, shaping the past, present, and future of everything that exists. As we look up at the night sky, we're not just seeing stars and galaxies. We're witnessing a universe being quietly, relentlessly pushed apart by an unseen force, one that we are only just beginning to understand.